Alrighty, folks. I'm calling this video written homework 4, question 4, hint. Okay, and I put here for real. The reason why I wrote that is the previous video I recorded and posted, I said on the board and actually in the title at first that it was this assignment questions 3 and 4. That was actually a video for question 2. So I don't know what I was thinking when I wrote that or made that video. But anyway, a student wrote back and said they watched the whole thing looking for when I was going to get to question 4, and I never did. So anyway, let me do a version here. So question 4, as written in on the homework, is this problem. So they sort of ask two things. They ask us to perform the division, and in the instructions for the entire homework is that we only know the definition of a fraction, right? And previous 107 material. So I can't do any kind of tricks, any fancy flip and multiply tricks. I just have to kind of work it all out. And I want to do that on the number line, okay? Once we do that, though, and once we figure out our answer, what we're asked to do then is kind of see, we're asked when in our work did it sort of become apparent that we've got the value 4/5 and we sort of multiply by 3, right? And sort of divide by 2. Okay, so that's what they ask. So again, they're not asking us to do this. They're not saying use that trick to find the answer. They want us to do it the standard way, or I should say the number line way, the long way, with our definition. But what we're sort of brainstorming is if I'm taking this quantity and multiplying by 3 and sort of simultaneously dividing by 2, then that's kind of like this, right? And that's our flip and multiply shortcut. Somebody said keep it, flip it, multiply, right? So that's sort of what's happening here. That's, again, we don't have this technique, so I'm not going to do that. But what the goal of this division problem is that after you do it and after you look at it, maybe we can start to explain where this technique came from in the first place, right? So when this technique, flip and multiply, was first mentioned in this class, I sort of put it back to the student who asked and said, you know, that rule may work, but if somebody asked why that works, could we explain that? And if we can't, we shouldn't really tell people to do stuff if we're not sure why it works or, you know, sure that it even does work. So we want to build it from the ground up. So what we're going to do in this problem, as you explain it, we're sort of justifying, you know, where this multiplication trick comes from. And we're also sort of taking advantage of something else. Again, something that we in our minds already think about as college-age students. But 3, when we say when are we dividing by 2, there's really no division by 2 here, but I see 2 in the denominator of a fraction. And a lot of us interpret that as 3 divided by 2, right? Which again is not in the definition of a fraction. However, we're familiar that, you know, that essence is sort of built into what fractions are all about. Okay, so that's, again, I like that I just chose that word, that what we're looking for sort of is not to use this shortcut in this problem, but sort of start revealing the essence of the shortcut and where it came from to begin with, okay? So let's jump in. And now, there's one way so the way that we always approach these division problems so far in this semester is by utilizing our 107A definition of division, which is missing factor, which means whatever 6/7 divided by 3/4 is, it's something. So I just happen to I like to use the question mark. So I want to rewrite that. And then what we did was, well, I want to write that, I should say. And then what we did is rewrite this in missing factor, which is our definition. So this means 3/4 multiplied by question mark equals 6/7. Okay? There I'm turning it to multiplication, but that's not a trick, right? That's actually our definition of division. So that's fair. Let me put by def of division, just since I would ask you folks to write it. Okay, now, as written, this means 3/4 of something, right? 3/4 of some unknown quantity or unknown length is 6/7, right? That's really what that means. The way that I've done some of these problems in the past, these missing factor multiplications, which came from division, is then I decided to commute this, okay? And that was sort of stylistic. At times that seemed to work out nice for us. I think we've done 1 or 2 examples, though, where I don't commute. I just kind of work it the way it works here. So I'm going to recommend doing it this way, and we'll see why, because I think it's going to reveal the secret of what's going on here. I've tried it the other way, and I can get the answer. This one's actually kind of not the easiest thing to do the other way, in other words, by commuting. Actually, I did it in a previous video, and then I realized my number line was too long, and I scrapped the whole thing. So I'm not actually going to do it now, because it took a while, and it was a little bit complicated. But I want to actually solve this version of the multiplication, the fill-in-the-blank multiplication problem. And so let's just do it that way, trust me, and then we'll see why, though, at the end. I think we'll reveal what we're looking for. So I don't have to do this next step, but let me just mention it. So I'm not going to commute the multiplication. So commutative property for multiplication says this: A star B is equal to B, here I'm using X. A times B is the same as B times A. And that holds for real numbers, for integers, for whole numbers. That holds. And sometimes we use a star in general or some kind of symbol for just a general operation. So A star B is equal to B star A. In general, for whatever operation this star would be, that is the commutative property. So when you define what a commutative property is, it's this. That basically, if you've got an operation, which means, for our sake, usually plus, minus, multiply, divide, right? Those are our main four operations. The commutative property of a particular operation tells you that if you swap the order of the two pieces that you're plugging in, you get the same answer. That's basically what that property means. There's another property that is not a property of an operation, but it's a property of actual equal signs. And so equal signs are not an operation. You're not really combining two different things. They are what's called a relation. They relate to quantities to one another. Less than signs, greater than signs, those things also are relations. They state a relation between the two sides. So I'll use different letters, but there's a property that says this: if C is equal to D, then D is equal to C, right? And because equal in our sense of numbers means basically is the same as. So if C is the same as D, then D is the same as C, right? So that kind of looks like I'm swapping the order. So that kind of looks like a commutative property. But this is actually called the symmetric property. Symmetric property of equality. All right, so of a relation. So it wouldn't make sense to say equality is commutative, but we can say that it's symmetric. Basically, which just means I can turn around an equation, right? If I've got an equation here, something with an equal sign, I can swap the two sides. And so anyway, here's a kind of a lengthy explanation of that. And so why am I even going to do that? Do I even need to do that? The answer is no. The only reason I want to redo it is I just like the way that the equation sentence sort of sounds if I do that. In other words, I'm going to write this: 6/7 equals 3/4 times question mark. Okay? If you're writing this up at home, don't worry about doing that. The reason why I want to do it is because we can interpret the equal sign as the word is, basically. So this says 6/7 is 3/4 of something, right? That's how I'm interpreting this. So I'm thinking multiplication is the word of, this is the word is. So 6/7 is the same as 3/4 of something. Okay, so I've kind of got an unknown something right there. Yeah, so anyway, let me set this up, set up my number line, and then we'll jump in a little bit further. Let me go, I'm gonna go, let's say, not that it matters to you, but I'm doing 4 inches bear with the silence. There we go. So I mentioned earlier I had the problem all good, and then my number line wasn't big enough. So here I wanted to use smaller segments. I happen to use that ruler to get them nice and equal. So here I got 1, 2, 3, 4, 5, 6, and 7 segments. Is my 1. Here's my 0. And let me hope for the best. I think that's going to fit. Okay. So let me locate 6/7 first of all. Then I'll get back to the little why I turned that around. And again, it's not really necessary to do. This says the same thing. Just space that out a little bit more. Okay, so let me set this up. I'm gonna kind of do this like one of those candy bar problems. Remember, I think it was I get mixed up with the question numbers. I think it was question 3 on homework 2, where we had the jumbo bar, right? I'm going to kind of draw something above the 6/7, Why? Because I've got my whole here, and I've got 6/7 marked off on that. But then I know that 6/7 is the same as 3/4 of something, right? So that's why I'm interpreting it this way. So 6/7 is 3/4 of something. So that means if I knew what the something was, then I would know that 6/7 is 3/4 of the something. Okay? So I can interpret that as 3/4 of something. I can also think of it as sort of another thing or another sort of unknown, but I can say 6/7 is 3 of something. Right? So let that sink in for a second. I'm saying 6/7 is equal to 3 of, of something. What are those somethings? Those somethings are quarters of the whole, right? So I'm just sort of slowing it down. Instead of saying 6/7 is equal to 3/4 of this question mark, I'm saying that 6/7 is 3/4 of the question mark, right? So kind of delaying it right there. Why is that even important? Okay, so let me draw this like jumbo bar or this bar of length 6/7. Okay, 6/7 is 3/4 of something, quarters of some unknown. So it's 3. It's 3 of something. Okay, 6/7 is 3 of something. Let me show that. Let me split that up. Split this bar into 3 of something. Right. So that's 3 of something. Now let me jump down to the other number line though and keep everything straight. So I've got 1, 2, 3, 4, 5, 6 segments down here. Okay, so those 6 segments make up the length of my bar. So those 6 segments I need to sort of break down into 3 of something. So I've got 6 segments that I want to sort of represent as 3 of something. How could I do that? Let me count up 2 of them. Right. So if I do 2 here and then come up, and then 1, 2 here, and then come up, and then 1, 2 here, and just show the little boundaries, I guess. Right? So what I did was basically from my 0 and the 6/7, because that's the length of the bar that I'm breaking. And again, I'll keep saying it over and over. Why did I do that? Because 6/7 is 3 of, or 3/4 of some quantity. Okay, so there, 1, 2, 3. It's 3 of something. Now, what are these things, right? What is it 3 of? It's 3/4 of our question mark, right? What does that mean? That means this chunk is a quarter of our question mark. If I have 3 chunks, that is all 3/4 of my question mark. Where is the full question mark? That is the question, okay? Well, 1, 2 of these segments on my original line is one of those chunks, right? One of those quarters of the question mark. And so these 2 is another quarter. These 2 makes another quarter. And so these 2 make another quarter, right? So I kind of tack that right on right there. And there we go. All right. Okay, so now what is my answer? So let me try to interpret this now. 6/7 is the same as 3/4 of a question mark. So 6/7 down here is the same as 3/4 of the question mark. Where's 4/4 of the question mark? That would be here. 1, 2, 3, 4/4. What fraction is associated with that? Whatever lives down here. Alrighty. And what is that now? Well, these segments, I didn't show the whole number 2, but they're the same size segments as these. Right? So those are 7ths. And if I'm at 7/7 and I go one more, I've got 8/7. Okay? Now, let's not go back too far into the flip and multiply trick, because if you do flip and multiply, you're gonna how are you gonna show the multiplication on fractions, right? So you could do an array, you could do a number line, but however you do it, or if you cheat and do something from outside this class, take a shortcut. I think when you do that, you're not gonna get lowest terms, so your answer may not be exactly what we're looking at here. Okay, but that's okay. And I don't even really want to go there, because then we have to start explaining what that answer is and how we convert to lowest terms, which we can do. We can explain all that now, but that's a completely other, that's more than we want to do here. However, what we do want to do here is, so not numerically, where did I flip and actually multiply, but where did I divide something by 3, right? So where did division by 3 occur? Let me color code this. Where did division by 3 occur? right? And I did that in red. And then where did multiplication by 4 occur? Where did, multiplication by 4 occur? Okay, and I know that's probably chicken scratch and then the sunlight, but where do those things occur? Well, remember when I kept over and over and over and over again reading this statement and then emphasizing different words of the sentence? 6/7 is 3/4 of something. So what did we do? We made this bar, this candy bar that's length 6/7, and we said, well, that's 3 of something. So let's divide that bar up by 3, right? Let's split that bar into 3 equal pieces. It sounds like, if you have a Hershey bar and you do that, sounds like you kind of divided it by 3 to me. Okay, so once we did that, then we identified what one of those quarters were. So now we knew what 3 quarters was the whole bar. So when we split that up, we identified what 1/4 was. Where did we do any kind of multiplication by 4? Well, I have, one of my quarters, so let's 1, 2, 3, 4, right? Let's produce all 4 of them. So is that multiplication by 4? I mean, it's a little bit kind of a loose interpretation here. But I would say maybe we divided by 3 when we split this 6/7 up into 3 pieces, right? That's a form of division. And then what did we do once we had identified what one of those pieces was? We counted up 4 of them, or we kind of combined or added up all 4 of them, or however you want to interpret that. Yeah, so I think that sort of answers the question. All right. One thing that was nice about this is my 6/7, needed to be split into 3 equal segments up there. 6 and 3, they share something nice, and so I didn't need to. I got away with just splitting these in a certain way. All right. So it might sometimes be a bit more complicated. Maybe we'll try more complicated ones together in class or in the future. But I kind of modeled this process a little bit off the ones from your homework. So I think your homework should go similar. If you mimic this process, I think you'll not only find the answer, but hopefully, and of course, in your own words, explain it. So don't necessarily just just try to rephrase what I did. Try to think about it in your own, and then come up with that explanation. But anyway, I think this is the way to go. If you commute this multiplication, try it. But I don't. For me, it's really hard to see these little things appearing if you can see them at all. Anyway.